let's look at adding and subtracting fractions. Now we're going to have some variables in here. Now here is a rule here. Let's look at the fractions a over c and b over c, and you want to add them together. They have the same denominator, so you can add the numerators. We get a plus b over c. So let's look at a specific example here. 4/17 plus 11/17. The denominator is the same, so you can just add the numerators together, and we should land up with 15 over 17. Now this next one, the numerators are unlike terms, so we can't add them together. So we get 7a plus 12 over y. Oops, better duck. And this here, let's say we have two fractions represented by a over c and b over c, and you subtract them, same denominators, then you just subtract the numerator. So we get a minus b over c. So let's see a specific example of that. 9/11 minus 4/11. So the denominator is the same. We can just subtract the numerators and get 5 over 11. Here's the case. Now the numerators are like terms, so we can subtract those and we can land up with 3b over 3x. We can cancel out the 3's and we'll get b over x. This one here, the denominators are the same, the numerators are like terms, so we can just add the numerators together. Now here we can do some canceling. We can 2 into 8 goes 4 times, 2 into 2 goes 1 time, so we get 4a over b as our answer on that one. This one, the denominators are the same. Now we have unlike terms in numerator, so we can't combine those together. So we get 6x minus 4 over 12y. Now we can factor out a 2 from the 6x minus 4, and notice that we can cancel 2 into 12 goes 6 times, and so we'll end up with 3x minus 2 over 6y. Oh, there's Newton there. Let's see how he's going to help us out. All right. Okay. Here's fractions that don't have the same denominator, so we have to get the same denominator. Now, what's the smallest number that both 6 and 12 go into? It's 12. So what we need to do is multiply 2 times the numerator and denominator of 1/6, so we get 2 twelfths. Now we have the same denominators, and we can add the numerators together, and we'll get 7 twelfths. Train's coming through here. I better duck. Now, 3d over 2 minus d over 5. What's the smallest number that both 2 and 5 will go into? It's 10. So what we need to do is to multiply something times the numerator and denominator of both, so we get 10 as denominator. So in the first fraction, we multiply 5 times the numerator and denominator. In the second one, 2 times the numerator and denominator. Now, we have the same denominators. We have like terms in the numerator, so we get subtract. We get 13d over 10. Here comes that train again. I better duck. It's dropping off a problem here. Now, our common denominator is going to be 3x. So what we have to do is multiply 3 times the numerator and denominator of that second fraction, and then our denominators will be in common. So now all we have to do is add the numerators there, and we'll get 11 over 3x. Now here's the problem. We have to get the denominators the same. We have to have factors of 3, 11, and c to make up our common denominator in this case. So take and multiply 11 times the numerator and denominator of that first fraction, and 3 times the numerator and denominator of the second fraction. Now we got 99x plus 12 over 33c. Now what we can do is divide 3 into each one of those terms, and so we'll end up with 33x plus 4 over 11c. In this case here, we get the denominators the same. We have to have factors of 3, 2, and a in the denominators to get the denominators the same. So in the first fraction, we can multiply 2a times the numerator and denominator, and in the second one, we can multiply 3 times the numerator and denominator. So 6a is our common denominator. Now, our numerators are unlike terms, so we can't combine them. So we get 8a squared minus 3b over 6a. Thank you.